Bismillahirrahmanirrahim. Hello everyone. Today we are going to discuss basic statistics that is applied in precision agriculture or the remote sensing and GIS applications or even in other studies to check the significance of the data and the studies. So statistical analysis commonly used are descriptive statistics, and it include measure of central tendency or measure of dispersion, normal distribution, regression, and geostatistics or the semi-variance analysis is used in the data when we are going to interpolate map in the GIS and the remote sensings. Why use statistics? In the past relied upon record keeping and financial computations, need more than just average yield per acre. Technology allows us to collect a lot of data, but how we can analyze the data and how do we interpret the data? We will analyze the data based on the suitable statistical parameters, equations, models, and we interpret the data about the significance of the data. Why statistically describe measurement? Our data sets are too large to understand or interpret. It provides a means of summarizing data and can be rapidly interpreted for making management decisions. Statistics can define relationship among variables. Statistical terms used are independent and dependent variable. We mostly studied in undergrad courses. Discrete and continuous variable. There are four types of data: nominal, ordinal, interval, and ratio. Here, 2D lattice display and 3D lattice display of the data is presented in the diagrams. What is central tendency? It's important because dimensions representing in agriculture are generally reported as a single expected value. A single value that attempts to describe a set of data by identifying a central or real location or value of a population. Normal versus skewed distribution, two diagram. The central, the more red line describes normal diagram, mean and median values are at the central position, and the skewed is far away from the normal point or from the mean position. Data skewness. Measure of the dispersion. Measure of dispersion describe the distribution of the set of measurements. Want to know more than just the center point of data? How widely is dispersed, or what is the range of values, or what is the standard deviation of the data? If the mean is average, then standard deviation is the difference from the average or the mean value. Measurement of dispersion terminology range. Difference between maximum and minimum value of the measurement. Standard deviation estimated as given formula in the diagram. Summation I to n value xi minus x bar. Bar represent the mean, square over n minus 1, and n are the number of observations, and its values are under root or square root. Measurement of dispersion terminology. Here it is presented the three different cases. If the 99.77% of the data are within the 3 standard deviation of the mean value, represents 95% within the 2 standard deviation, these two lines, and 68% of the data is just 1 standard deviation, or the value is just 1 uh, unit from the mean value. 68% data is with this 1 standard deviation. Coefficient of variation, a magnitude of difference between large value and their means tend to be large. Difference between small value and their means tend to be small. A high yielding field is likely to have a higher standard deviation than a low yielding field. Thus, variation about two means of different magnitude cannot easily be compared. Comparison can be made by calculating the relative variation or the normalized standard deviation, or it is also called coefficient of variation. Correlation also used statistics to establish if one variable is related or connected to a second variable. What is the relation? Does the changing in soil pH change the response of a wheat yield? Will the glacier melting increase the runoff in the river? Will the increase in temperature will increase the rainfall intensity, or the These are the studies that describe the two variable relationship. Attempts to show the relationship between paired variables only deals with two factors. Here, correlation is presented. Correlation coefficient or R is that Meyer's. Here are the positive and the negative correlation. The first diagram represents positive correlation between x and y, two variables, and the second diagram on the right side is represent the negative correlation. The correlation coefficient R lies between -1 and 1. The positive value indicates that x and y tend to increase or decrease together. Regression, linear regression and multivariate regression determine the strength of a relationship between one dependent variable and a series, three or more independent attribute variables. So, the models for the regression equation are presented here is equal to as y is equal to a plus bx plus u, or y is equal to a plus bx1 plus cx2 or dx3 plus u. Both formula represent a linear relationship to explain data. Most data not perfectly linear use this association to test for significance. Test for significance, a t-test of two standard deviation means you can be 95% confident that outcome, the historical average return, did not occur by chance. There is still a 5% probability shaded area that the true value, for example, expected return is 0. So statistically significant 2.5%, t-test represent 95% reliability, and the diagram represent probability of the occurrence of the significance, and the data are the uh, validate or the result interpretation of any data that we consider for research. Thank you very much. If you have any question, we will discuss when during the online lecture on the Google Meet, on the Persian agriculture, the remote sensing classes. So this is the general topic that is valid for both courses. Thank you very much.